Sometimes people use encoding and encryption as they mean the same. But that is a common mistake. And sometimes you might have seen hashing be confused as an encryption mechanism. In this video, you will see a review about all these terms. Hello guys and welcome to SecuCybers. Today let's learn what is encoding, encryption and hashing. Encoding can be defined as a technique to transfer data from one format to another so that it can be understood and consumed by different systems. Basically, encoding has to do with information representation. When you see this photo, you can easily represent it in the terms of letters. This is a handy representation for humans like you and me. But not so easy for the computers. What usually happens in this case is that transformation of these sequences of characters into these seconds of bits. When you take the word and sequence of bits, you have two representations of the same information. The letter-based representation is usually understood by humans, like me and you. And the bits representation is more suitable for the computers. Commonly you say that the sequence of letter has been encoded into the sequence of bits. So encoding is just a transformation from one type of representation to another, while representing the same information. Usually, it involves conversion tables. Encoding ensures interoperability between systems. Yes, I know it is a big word, but encoding allows systems that use different data representation to share information. Encoding has no security purpose. Anyone that knows the conversion algorithm can encode and decode data. The conversion algorithm is not kept secret. And finally, encoding is reversible process. You can transfer one piece of data from one representation to another, and then go back to the original representation without information loss. Encryption, on the other hand, is a technique that makes data unreadable and hides the code for the unauthorized party. So basically, encryption is a mechanism that transforms data into a different representation so that anyone seeing it cannot understand it, but you may be wondering, isn't this transformation the same as encoding, after all? How can a human being understand that this sequence of bits represent the word bus, rather than me telling you it does? In fact, this question is not so far-fetched. In a way, encryption is a form of encoding. It transforms data from one representation to another. For this exact reason, sometimes people tend to confuse and use encryption and encoding as if they mean the same thing. However, the purpose of encryption is different from the purpose of encoding. The encryption technique aims at making the data unreadable and hard to decode. This is the opposite of encoding. Encoding aims and make the data as much understandable as possible across the system, while encryption tries to make the data non-understandable unless they have an authorization for reading it. The main goal for encryption is to ensure the data confidentiality. For example, protecting the data from being accessed by unauthorized parties. So, while encoding makes its conversion algorithm as public as possible, encryption will rely on well-known algorithms whose data transformation is based on sequences of numbers or letters called keys. Some examples of key-based encryption algorithms are symmetric key algorithms. This is basically using the same key to encrypt and decrypt the data like AES algorithm. And then there is asymmetric key algorithms. These algorithms use different pair of keys, one to encrypt and another to decrypt the data. Like pure encoding, encryption is also a reversible process as well, although just for authorized people. The main goal of encryption is to make data decryption, without the key, as hard as possible. Now that you understand the difference between encoding and encryption, let's move ahead to hashing. Hashing is a technique to generate a unique fixed-length string, a hash, strictly depending on the specific input data. In simpler words, the original data, let's say, a text that you have sent to your friend, is given a hash. The hash is generated on the input data, that is the message you have sent. And any change to the input data will lead to a change in the hash. So if the message you send is hi, and your friend receives hello, although the meaning might be same but the data here is altered, this will lead to a hash different from the input data. In other words, hashing ensures data integrity. Hashing algorithm must have 5 following assumptions. First one. The resulting hash has fixed length. Second one. The same input always produces the same output. This basically means that if you have sent a text like hi, then your friend should receive the same message. And the third one is, multiple different input should not produce the same output. Fourth, it must not be possible to obtain the input data from the output data. This implies that hashing is not a reversible process, unlike encoding and encryption. And 5. Any change to the input data implies a different resulting hash. As you have seen today, that encoding, hashing and encryption have their specific purposes and features. Confusing their capabilities and roles in your system may lead to disastrous consequences. So, I hope that I was able to clear everything. If not, you can always comment down your doubt below. I'll be happy to answer. Don't forget to like, share, subscribe for more such content. Thank you.